Hello everyone. In this video, I'm going to talk about Arcus functions and their relation to logarithm function. First, we have arcsine function, which in last video we defined as e to the ix minus e to the minus ix over 2I. Here you can see a proof where I show arcsine is actually called minus I logarithm of x plus or minus 1 square root of 1 minus x2. So in the lower section, you can see that you can form a quadratic function in e to the ix and solve it for e to the ix, get y plus or minus a square root of 1 minus x cubed, y squared, and then you take the logarithm and divide that by I to get the result above. Arc cosine follows almost exactly the same procedure. As you can see, the only difference is that you don't need to divide by I, and you get a square root of y squared minus 1 instead of 1 minus y squared. Other steps are identical. But perhaps the most important Arcus function is arctangent, that is defined as 1 over 2I logarithm of x minus I over x plus I. Now this one actually doesn't even involve the Euler's notation for complex numbers. Rather than that, it uses Gaussian integers. So on the proof below, you can see that it's defined as integral of 1 over x2 plus 1, and then you can rewrite it as logarithm of x minus I minus logarithm of x plus I, and get the formula above. In the next section, we will discuss about arctangent function and other Arcus functions. Hello again and welcome to the next section. So here we have domain coloring version of arctangent, arccosine, and arcsine functions on complex plane from I1 plus I to minus 1 minus I. So first function to discuss is tangent, arctangent. As you can see, the function isn't even continuous between positive side and negative side of real numbers on complex plane. And as you can see, there are two poles, one here and another one down here, which happen at I and minus I, so on the imaginary part. And because of those two poles, asymptotes actually, you have a non-continuous function from from the positive side to negative side of real numbers when you go far enough from 0. However, in cosine or arcsine, you don't actually see any discontinuity. As you can see, all the green lines here and here are continuous as opposed to the green lines below or above these poles. So you can see that these two functions are continuous unlike the other one and have 0 here. Well, another thing you can observe here is that here where you have such angles in angles in the green lines, you may realize that here the plane created by complex arc cosine function and arcsine functions are actually two planes. So if you think of it as a Riemannian manifold, it's gotten through itself and below itself once. That's because as we discussed earlier, it's all of those functions have actually two answers because they are formed by quadratic equations. Thank you for watching